These are the basic facts. I know you know already, but you know that sine is smaller than or equal to 1, as with cosine. Sine squared and cosine squared are smaller than or equal to 1. E to the x, just thinking about the graph of e to the x, you know it's always bigger than 0. Same with e to the negative x, which looks like that. Secant squared and cosecant squared. So these are the cups kind of graph, but if you take and square each of them, then that would mean that all the cups would be above the x-axis. So then, let me make this bigger here. So think about comparing these two fractions. This has more in the denominator. Just think about the number 1/9 and 1/8. So more in the denominator makes the number smaller. Here, this one has more in the denominator. So that would make this number 1/11 smaller than 1/9. Okay, so we're going to always take into account that the x values are positive, so which would be smaller is what I would encourage you to think of. This has more in the denominator. How about here? This has more in the denominator. And then here, so I know sine squared is smaller than or equal to 1, so I can make the inequality this way. Which one has more in the denominator? This one. Which one has more in the denominator? This one, because this has subtract 2. Which one has more in the denominator? This one, because this has subtract 1. Okay, so I know that always secant squared is bigger than 1, and so that's going to be bigger than or equal to 1. So I'm just going to put that, and I don't care whether you put the equal sign in or not. You can always just leave it off. How about this one? So cosine, the biggest cosine gets is 1, and so that would be smaller than or equal to, or just smaller than. I'm just going to go in general with no equal sign. And then this, okay. So now let's go to this. So again, if it says converge or diverge, you're looking for the plus or minus infinity, which is the horizontal asymptote, or where is the vertical asymptote. So neither of these are plus or minus infinity. So I need to think about where the vertical asymptote is, and I can see that the vertical asymptote in this problem is x equals 0. So it's necessary for me to split it up at 0. So I'm going to rewrite this as x to the negative 3/5 power plus 0 to 1, x to the negative 3/5 power. So it is necessary, since they're limits, that you do each of these separately. So if I take the limit and it's 0, then I'm taking the limit towards. So negative 1 to t, right? That's what I put the t up here. X to the negative 3/5. So let's do it. So I add 1 to the exponent, so I get 2/5 times 5/2. And then between negative 1 and t, limit as t goes to 0. So then I put the t in, 2/5, x to the 2/5. I'm sorry, I meant to put the t in. I tried to put the t in, missed it. T to the 2/5 minus, oh dear, minus a 2/5 negative 1 to the 2/5 power. All right, let's think about this. If I'm putting in 0, well, that gives me 0 there, right? And if I square the negative 1, that gives me a positive 1. And so then this whole integral gives me negative 2/5. So what happened is that this first part gave me negative 2/5. So it did converge. So now it's my job to go do the other integral to find out if it converges. And if it converges, then I add those two together. All right, let's do it. So then here I would say limit. This is, the limits are very important. So t to 1, and I dropped the negative sign when I rewrote it there, didn't I? X to the negative 3/5 dx. So limit as t goes to 0. So I get a 2/5 x to the 5. X to the 2/5. No, 5. Sorry, I'm getting my numbers all mixed up here. So I get 2/5 here, and then 5/2 here. Okay, and then I'm going to plug in t and 1. So that limit is t goes to 0, so 5/2. I'm going to plug in the 1, so I get 1 to the 2/5 minus 5/2 t to the 2/5 power. So that gives me just 5/2. It's good because when I plug in t equals 0, that's gone. So that's the answer from the second part. This is the answer from the first part. And so I add those together, and that is the integral.